All right, again, good morning. Today we continue our trek through solving quadratics with completing the square. If you're in for a little bit of amusement later or a catchy way to try and remember how this goes, check out down in the bottom of this lesson, DJ Pi's hit single, If You Can't Factor It, That's Okay. Oh, gracious. It's been a long week, so we're just going to kind of jump right in here. So completing the square allows us an opportunity to rewrite an expression, to make it a little bit easier to solve in some cases if factoring doesn't work or it's like complicated. I'm going to ask you to really not pay a whole lot of attention to this because really it's just saying we're going to turn it into a perfect square trinomial where the first and the last terms are perfect squares we can get here, but we don't need to get on all the variable stuff here. So find the value of c that makes the expression a perfect square trinomial. Then write the expression as a square root binomial. Now that may sound really complicated. There's a whole lot of math lingo going on here. You're like, a c, a perfect square trinomial, square of a binomial, what are they asking? This is all we're going to do, okay? We're going to take your b value. Okay, our b value here is -8. Okay, we're going to take -8. We're going to cut it in half. Okay, that's -4. Then we're going to square it. Excuse me. And what you're going to learn here is this is going to be the actual steps that we're using when we're completing the square. So it's always half b, square half b, okay, which is 16. This is the c value, okay? This is the first part of the question that makes this a perfect square trinomial. Because if you think about that for a second, I should have written a little bit smaller. Perfect square, perfect square. What do I square to get each of those things? And so I'm going to make a squared term here. What times itself is 16? 4. But be careful, don't put +4 just because you see +16. It's always going to be that sign that was in the middle. And then this, ladies and gentlemen, is the square of a binomial, 2 terms. Okay? So it's going to be that same way we do it each time. Now, for a moment, I'm going to go to number 3. I'm coming back to number 2. I'm not going to try and wiggle my way out of it here. I just want to have one that's a little more normal again for us before we get rolling. So my b is 26. Again, same steps every time. We're going to have b. We're going to cut it in half, divide it by 2. We're going to square half b. That will be this c that we are looking for. And we're going to label things a little bit more this time. This is your perfect square trinomial. Why? Because it's 3 terms, trinomial, and both beginning and ending term are perfect squares, perfect square trinomial. Then, I'm going to show you a cool trick here too. Okay, what do we square to get 169? Well, we just saw that back here, it was 13. And again, go to that sign in the middle. Okay, and this is your square of a binomial. But here's the trick to make our lives easier. When you take your b and divide it by 2, your half b, that's going to be the same value, the value that you're squaring here that you put into the parentheses for your binomial. These will always match, okay? These will always match. Now, why is that important? That's why I skipped number 2 for the time being. Now, let's go back to number 2. Number 2, my b value is -3. -3 divided by 2 is a decimal. It's 1.5. We're not going to use decimals with these. So what we're going to do, that's all I can do. That's b divided by 2. We're going to square it. You're like, ooh. Now, I'm going to do it on the calculator here just to show you something. But it's really not a big deal. We really don't need the calculator for this. I'm going to turn this down a little bit because I'm getting some glare. Or I can just move me. There we go. So if I do -3 squared, don't want the decimal. 9 over 4. Now, I mean, just think about it for a second. You'd be like, oh, yeah. 3 times 3 is 9. 2 times 2 is 4. And we're just squaring each one. So the fraction really is just having two separate inequalities. Two separate exponents that we are dealing with, the negative 3 squared and the 2 squared. And this is why knowing the little trick I just showed you the step before this is so important. Who in their right minds would want to factor x squared minus 3x plus 9/4? Okay, here's where the trick comes in, and you can amaze your friends with this. You can get something like that there, but now you know the trick. Whatever number was in the parentheses from when we divided our b value by 2, that's what goes in there. Square of a binomial. Now, usually at this point when I have people in class, they start to ask me, hey, wait a minute, where did the 3x go? Or where did the 26 go? Because I mean, I see this and I see how that's squared, but like it disappeared. No, it didn't. Okay, let me show you on this one. It's a little easier to see. If I take x plus 13 squared, it means I have 2 of them. Okay, if I FOIL this out, if I multiply this out, so I got first, outer, inner, last, and I combine my like terms in the middle. Okay, same thing. This is just a condensed or a smushed down form of this. They're the exact same thing. Okay, so what does that have to do with completing the square, solving a quadratic? Well, what we're going to do down here, okay, we've got some steps, and again, you're always going to have access to these steps. So it's not like you have to fully memorize them, but the quicker you know them, the easier it's going to be. Make sure the number in front of x squared is 1, okay? If not, you're going to divide by the x squared. Oh, my head's going to get in the way again, isn't it? Coefficient. Get me out of the way one way or another. Okay, most of the time we're not going to have to worry about the step 1 dividing everything, but occasionally, and we will here in the examples as well, we will have to do that every once in a while. Write the equation in the form x squared plus bx. Add blanks to each side. Okay, I'll explain that more when we get into the first one. There's not a real good way for me to put that here in general. Do your b divided by 2 squared, add it to each side. Factor is a binomial square. So we just got done doing these two up in part 1. And then take the square root of both sides and solve for x. And just remember, these are quadratics. So you got to have 2 answers. Okay? So, solve by completing the square with a 1 for a leading coefficient. We're going to keep life simple. Okay? Step 1. Make sure the x squared coefficient is 1. Check. Okay. Step 2. Write the equation in the form x squared plus bx. In other words, I like to call this x's alone. In other words, if you have x, you get to stay. If you do not have x, you need to go away. So we're going to add the 3 to the other side. And I am going to do my best job trying to label my steps here, at least on the first couple, so we can literally see where everything is at. Okay, now we got to do a little side work. Add b over 2, well, b divided by 2 squared to each side. Okay, there's my b term. It's always the number in front of x. So if my b is 10, I got 10 divided by 2, which is 5. Squared, which is 25. I like doing the side work even when I know what the numbers are pretty easily, just because it's going to help me with that sneaky step later. So now, when we add blanks to each side, we're going to call this step 2a. We're still in step 2. You'll get to a point that you can combine the two steps that I'm doing here into one, but the first time I really want to make sure we're seeing what's going on. So that 25 that we just got, okay, actually this is step 3. What am I doing? Okay, I add the 25 to each side. So I'm still keeping balance, okay? If this was a scale, nothing's changed. And so now, once I do that, we're going to do some factoring. We're going to get our binomial square. X, I can either think about what multiplies to 25 and adds to 10, or I can just steal the number from in the parentheses over here if I did my side work. And all of a sudden, excuse me for a minute. Oh, excuse me. Thank you. And I come back, and now the last step is to take the square root of each side. On the left, squared and square root cancel. Now, on the right, 2 things to remember. First thing, plus minus, because there's going to be 2 answers. Okay? Second thing, if your radical breaks down, you're like, oh no, you have to break down your radical. So again, if you need, bust out your perfect squares part of your help sheet, or maybe you made a list, or maybe you just look at that list that we had in the last section. So I look, and I'm looking to see if there's any of these numbers that go into 28, and the bigger the better. 4 goes in. So 4 times 7. Square root of 4 is 2. That gets out of radical jail, so 2 square root of 7, and we're almost there. Get x alone. Got to minus the 5. And as we talked about in the last lesson, it can hang out on the same side. These do not get put together. You're like, well, why not? Why can't I do negative 5 plus 2 and negative 5 minus 2? It makes sense that I'd be able to. Here's the deal. Here's what I would ask you. If I told you negative 5 plus or minus 2x, because I'm treating the radical like I would a variable, would you tell me the answer was negative 3x and negative 7x? You'd be like, well, no, those are different. Right. And so are these. Okay. The only time we could combine this further is if there was no radical. Okay. If they were just coefficients. If that's the case, then we can do that. Okay. Let's play with another one. Now, number 5, I like number 5. Why do I like number 5? Because it already has no coefficient in front of the x squared. It's a good thing. Step 1, check. Okay, write the equation in the form x squared plus bx, already done. Check. Number 2, done. So now I just got to start doing my side stuff. So I'm like, all right, so negative 6 divided by 2 is negative 3. So half b square half b. Whatever value I get to add to both sides is always going to be positive. As you can see, even here when it was a negative, negative times negative is positive. So I write x squared minus 6x plus 9, because there's one of my blanks, equals 8 plus 9. There's my other blank. So what do I do? Well, here, again, x multiplies to 9, adds to negative 6, or be sneaky if you did your side work. It's really just half the b term every time. So now I'm to here, and now we just need to solve. So we go to get the square root off. We zap that. Remember your plus minus. 17. Let's see here. We've said before 1 doesn't really help us. 4 doesn't go in. No. Nope, nothing goes in this time. Okay. So we get that set. Add our 3 over, again, which is not a like term. This has a radical. This does not. And I'm set. Okay. So we're just kind of messing with these things a bit. Now, can it get ugly at times? Yes. So we are going to skip past number 6 and go to number 7, because number 7's ugly. Okay. So what is so bad about number 7? Well, let's see. Nothing in front of x squared. That's good. Don't have x's alone yet. So x squared plus 5x plus some random number I'm going to find here in a minute equals, add my 1 over, plus some random number. Okay, what's the random number going to be? There's my b term, 5. 5 over 2 is going to be a fraction. So that's as simple as the value is going to get because we don't do decimals. 25 over 4 is my magic number. And this, again, ladies and gentlemen, is why I am such a huge fan. Huge. I can't even begin to say. Huge fan of putting this little step in right here. Because now 5 halves, I don't even have to think about what that value is. Okay, now 1 plus 25 fourths. I challenge you to try and do this using your brain, because if this is in fourths, 1 is fourths would be 4 over 4. So 4 plus 25 would be 29 over 4. Again, if you're not sure, I don't want that being the thing that causes you not to do a problem. So if you need to, again, just put the fraction in parentheses, math, enter, you can get the 29 over 4 that way. Okay, not a big deal. Now we're ready for the moment of truth. And we're going to get a bit of good news here, surprisingly enough. At first, we're like, oh, all these fractions are going to, okay, plus minus. Okay, 29. I tried looking at my roots. I'm like, 4 doesn't go in, 9 doesn't go in. Nope, nothing goes into 29. But what's the square root of 4? 2. You can separate fractions, okay? You can look at this like it's the square root of 29 over the square root of 4. That's legal. If you can break down one and not the other, you can. And here was the good news. Now they have the same denominator. I'm not going to have to get cute with this. So I subtract that over. I can keep it as a fraction, or since they're both over 2, I could write it as one big fraction. These are equivalent. They're the same. So don't freak out if sometime like you're looking at the key and the key says this and you have this, they're the same. Okay? So just something to keep in mind. So as we flip over here, all right, solve by completing the square with a lead coefficient, not a 1. Okay, here's all we got to do here. Nothing complicated. Whatever the lead coefficient is, we're going to divide everything by it. Now, we're not factoring here. We're just dividing, straight up dividing. X squared minus 2x minus 4 equals 0. And now it's the same thing. So I do my stuff. I say, okay, x is alone with a blank. That 4, when it moves to the other side, remember you're doing an opposite when you move over. So 4 plus my blank. Little side work. B divided by 2 and square it. Get that in there. And now I just do those last steps. X, steal the number from my side work, minus 1 squared equals 5. And we're almost there. So you start to see, even though there was a lot of steps it looked like before, once you start to get the hang of things, it's really not that bad. 5 does not break down. I always check to make sure, but a lot of the time it's not going to. And we're set. That's the only difference. Just one step of division at the beginning, everything else is perfect. Okay, now, little twist. I think you're going to like this, though. Write the quadratic in vertex form, okay? And then find the vertex. Complete the square. You're like, complete the square? This looks totally different from what I was doing. Here's how this one's going to work, okay? When we go to do these, we're not going to move anything at the start. We're not going to get x's alone directly. What? Okay. Follow and learn here. We're going to put a blank on the y side. We're going to section off the x's with a blank, but I'm not moving the 11. Okay, the 11's going to stay. Because vertex form, remember, here's what we're trying to get this to look like at the end. Because then my vertex is going to be right there. That's back from when we were graphing with our quadratics. So other than that, our steps are going to be identical. We're still going to take our b. We're still going to divide it by 2 and square it. That's still going to be the value that goes in our blanks. And again, keep this stuff out when you're working on stuff. It's legal. This is going to end quick, though, this one. You're going to love it. Gonna love it. Get it into my square of a binomial. X minus 4. And now, look, the only thing keeping me from having this done is that 16 needs to get subtracted over. And when you're doing it in vertex form, the 16 actually has a place to go and combine with things. So there is my vertex form. And my vertex itself, remember, opposite of H, K. Oh. Now rewind and look at this again if you need to, but the blanks are all going to be in those same spots. Now, the last thing I'm going to mention, if you have access to a graphing calculator, okay, how could you help get answers to some of these problems? Now, I'm going to come back up to number 8 here for a moment. I'm going to type it in. 3x squared, this would work on any one that you do. Okay, if I go and I graph that, okay, I want to let you in on a little secret. I'm going to come out of this graph for a second because I want you to see something. 1 plus the square root of 5 and 1 minus the square root of 5. Because I already knew what the answers are here. Okay, so 3.2 and negative 1.2. Okay, get that in your brain. 3.2, negative 1.2. I'm going to tell you in advance. I'm going to show you. Negative 1.2, 3.2. You can find, we're going to jot this down first, then I'm going to show you. Find the x-intercepts or zeros. Okay? And when we did that back when we were doing our applications, I'll do it on one. It's second trace. We want a 0. And so what I'm going to do is I'm just going to find this one to prove my point. So as close as I can. 1, 2, 3, enter. 1, 2, 3, 4, 5, 6, enter, enter. Negative 1.23. And the other one would be 3.23. Okay? So you've got some practice completing the square over here. Please do that. If you run into questions, let me know. And do check out DJ Pie's video. We're trying to get him to #1 on the charts. So other than that, have yourselves a fantastic day, and we will see you next time.